Hello everyone, welcome to Semicontalk. Today, let's talk about NAND memory. NAND is a type of memory and used to store data like photos, videos, or some other files as well. It is used for smartphone, USB, SSD, and others. If you have a chance to open smartphone, it looks like this, and capacity can be 128 GB, 256 GB, or 512 GB depends on product. Usually, NAND package looks black because of black color of mold compound. But NAND in Apple iPhone applies conformal shield for EMI shield, so its color is silver gray instead of black. If you want to know about conformal shield, please check my other video. These are some NAND products from Samsung, Toshiba, now Kioxia, and Micron. And package type is FPGA or SCSP. Actually, same package structure with different name by company. Here is a NAND die photo and detailed structure of memory cell inside of die. 3D NAND for this case. This is cross-section of NAND package and here is NAND memory dies. In this photo, there are 8 stacked die. Usually, die attach film is used to attach dies, especially for multiple die stack. If you want to know more about die attach film, please check my video for that. Wire is used for electrical interconnection between die and package substrate and die to die as well. These dies and wires are protected by mold compound. And this is 2-layer package substrate for NAND package. NAND memory is not complex device. That is why this package uses simple 2-layer package substrate. So, NAND package has these elements. NAND package has controller die and it can be located within the package or outside of the package. Usually for smartphone, NAND package has a controller die inside of the package and it uses wire bonding for interconnection. This controller die can be located at the top of memory dies, at the side, or at the bottom. But for faster data processing, some NAND memory companies are thinking about flip chip controller die for their future NAND product. NAND memory device has two different types. One is 2D NAND and the other is 3D NAND. As its name implies, 2D NAND integrates memory cells side by side, means horizontally within the die. So, in order to increase memory capacity to store more photos and videos, we need to stack more dies vertically. And limited packet thickness requires thin die to stack more dies. So, wafer backgrinding technology is important. Then die thickness goes down to 35 micrometers for some cases. How about 3D NAND? As the resolution of photos and videos is increasing, file size of these is increasing as well. So, we need more memory capacity to store these. But 2D NAND is not good enough, because there is a limitation of maximum number of die we can stack within a package, and we cannot increase NAND packet thickness either. Idea of 3D NAND is to stack memory cell within the die instead of die stack. So, memory capacity of one 3D NAND die is much more than 2D NAND. It is a similar comparison between house and apartment. We can see multiple layers of memory cell in the die, 32 layers in this photo. Let's compare memory cell thickness of 2D NAND and 3D NAND memory. Typically, 300mm wafer thickness is around 775 micrometers. At the left, there is a 2D NAND and its memory cell thickness is less than 1 micrometers. For 3D NAND, memory cell thickness of Samsung 92 layers is more than 6 micrometers. And Toshiba 96 layers is more than 7 micrometers. As you can see, memory cell thickness of 3D NAND is much more than 2D NAND because 3D NAND stack memory cell within the die. Not to damage these memory cell layers in 3D NAND, companies are considering plasma wafer dicing, which is a special wafer sewing technology. This memory layer of 3D NAND goes up to 176 layers. In November 2020, Micron announced 170-layer 3D NAND and followed by SK Hynix at December 2020. In February 2021, Kioxia announced 160-layer 3D NAND. For each NAND memory cell, there are 4 different structures: SLC, MLC, TCL, and QLC. SLC stands for single level cell and can store 1 bit per cell. MLC is multi-level cell and can store 2 bits per cell. TLC is triple level cell and can store 3 bits per cell. QLC is quad-level cell and can store 4 bits per cell. SLC is more expensive but robust than others, and QLC is cheaper than others but least robust. How about suppliers and their market share? Samsung, Kioxia, Western Digital, SK Hynix, Micron, and Intel are major suppliers of NAND memory. For global market share, Samsung is number 1 with 33%, Kioxia is number 2 with 20%, and Western Digital, SK Hynix, Micron, Intel for others. Thanks for watching and have a nice day. Bye bye.